Hello all. Today we are solving LeetCode problem number 2977, minimum cost to convert string part 2. So yesterday we have solved the first part, and the only difference between the first part and second part is this question. Yesterday's problem we had the changed values as characters, but today this is a string. So because of this the complexity is has become very hard. So this is a hard problem. So let us see how we can solve this problem by reading through it and running through the example. So there is some certain rules also here which is given in these two part. Other than that, everything remains the same, similar to yesterday's problem. That is, our task is to uh, we are we are given a source string. Our task is to convert the source string into target, and we have to return the minimum number of cost required for this conversion. And we are given this original uh, array and changed string array and cost respectively. So this can be written as original, changed, and cost. So from BCD you can change to CDE, and this cost us 1. I'm reading through the second example for better understanding of this problem. And FGH to THH, which cost us 3, and THH to GHH cost us 5. So these are all the possible or conversion from change to original. Original to change, and this is the cost which will cost us for this conversion. So using this, we have to convert the source to target. So that is the task. If we are not able to do that, we have to return -1. And the main set of instructions given in these two part is, you can read through the problem, but I will explain here. So if a change happens for a substring example, we can have these three as a substring, which is A, B, C has undergone a change. Instead we can have it B, C, D, not A. So B, C, D, I think it's not visible. So BCD has undergone a change and it's been converted to CDE. So since it's been converted, you cannot reuse the substring. So this will be you will have the updated string as A, C, G, E, D, C, and so on, right? So this is the converted part. So for the next substring conversion, you cannot consider this E or D, which is already being converted in the process of the previous iteration. You cannot consider that. So that is the thing which is being mentioned in that particular rule, right? So how do we solve this? So also here you can note in the problem, it is given that if a character that is at index I in source and target is same, you can ignore it, meaning you can move to the next index, and then you can calculate or you can fetch the substring and then process it, right? So that is what they have given here. So before getting into the approach, I will explain how we can convert the source to target. So we have A, B, C, D, E, F, G, H, and target is A, C, D, E, E, G, H. So B, C, D is here, which can be converted into C, D, E. So you have A, C, D, E, and E, F, G, H. So this is the converted part, and this will cost us a total is 1 now. So in the next iteration, you have E as common, so you can skip E and E here as well. So you have FGH. So FGH can be converted into THH. So this will become ACDE and ETHH. So this is the conversion which will cost us 3. Yeah. And in the third and last one, you can convert THH into GHH, which is nothing but the answer, right? So this will, again, I will change the ink, green, yeah. So this will again get converted to A, C, D, E and G, H, H, which will cost us 5, which is nothing but 9. So 9 is the total cost. So that is what we are returning, and this is the target, and the target is same as the target which is given here. Source is being converted into target. So this is the this is how we solve this problem is. But there is, you can notice here, you have two types of decisions. So one is to compare just the character with index with I, and the next is take substring and convert, right? So this will result in, you can form a decision tree. Basically this will result in decisions, and eventually you can form a decision tree out of it, which is nothing but you can solve the problem using DP, dynamic programming. And also for this particular substring calculation of cost, you will use Dijkstra, because those these given inputs here, this can be represented in the form of graph, right? So due to this reason, this we can use Dijkstra, right? So this problem can be solved by combination of Dijkstra and DP. So this is how we are going to solve. So before solving this, let me write down the graph, draw down the graph for understanding. So we have a node BCD, which could be converted into CDE, cost us, the weight is 1, and now we have FGH, which can be converted into GHH, right? So FGH THH, which cost us 3, and THH to GHH. So this can be from GHH, which is 5. So this is the given graph with the weight mentioned here. So with this, now we can start the DP operation as well. So before writing down them, let me change the color of the ink, and source, target. So source is A, B, C, D, E, F, G, H. A, C, D, E, G, H, H. Right? So now you are at this point, you start at this point, the I is here. So you have two decisions. So TP, I will write it as TP, or yeah, let this be the start. You have two decisions, which is you can choose I which is I plus 1. You start from 0, right? So I plus 1, or you can have I plus L. L is nothing but the size of these words given in the original and changed. So size of words in original, L, right? So here you can say these two are equal. If you use I plus L, there is nothing here starting with A, so due to which there is no conversion from original to changed for A B C. So it's better to go with this one, so this will be cancelled, right? So we move here, so which is I plus 1, so we have the pointer I plus 1 at here. Now again we have two choices, I plus 1 and I plus L. So at this point you can see this, these two are not equal, so this is not possible. So I plus L, you can see BCD, and if you check BCD here, you can see BCD here, and to convert BCD to CDE you can use one operation which will equal this CDE value in the target. So if we continue this, in the meantime, since it is equal, we add total equal to 0. Since it is equal, it is 0, and since the conversion takes place from this uh, substring, we add the cost of the conversion, and now the updated I will be at this position, I plus L, and I will be at this position again. Now you have two choices, I plus 1 and I plus L. So again you can see here I both are equal and there is nothing starting with E, so due to which this will fail, and this is what we are going to follow here. So this will be 0 since both are same. So now the updated I moves to this position. So let me change the color again to black. Yeah, so in this position you can see the new substring I plus L. Okay, this is I. Okay, now again you have two choices. I'm sorry about that, little bit confused tied to the diagram. I plus 1 and I plus L. I plus 1 is not possible, so we choose I plus L, which is E F G to G H H. But you can see here E F G, you can just convert E F G. Sorry, this is not E F G, this is E F G H. I'm sorry about that. E F G H. FGH to GHH. So FGH, this can be converted to THH in the cost of 3 operation, and THH to GHH. So this is how you convert. So for finding this shortest length, so because there is only these way, right? You do not have any ways to find from for converting this source to this target. So this is the place where you use Dijestra's algorithm, right? So for this conversion it is 3 plus 8, so out of Dijestra's you get 8 as the output here. And now after doing this you have reached the target, and that will be the base case. And now return. So since we have formed this decision tree, we can solve this using memoization, and we are using Dijestra's algorithm also here. So in yesterday's problem also we have used a map to reduce the time complexity for Dijestra's. So similarly we will do the same thing, and this is how we find the solution. So with all this observation, let us go ahead and code this up. The first part is to create the adjacency list here, right? So because we need to create the graphs, so we need to create the adjacency list. So now adjacency list is equal to default dict pass in list, right? So now we have to iterate through this original changed and cost, and we have to build it the same way which we have done in the previous problem as well, based on the from node to two node and with the weight of the path, right? So for we can use original b o change and weight using zip changed, then cost using this adjacency of key value will be o dot append. Here we have to append the tuple that will be the weight and the node, right? So the node is c here, right? And now we have to define the Dijkstra's algorithm. Dijkstra's algo. So we are passing in starting and the target, right? Starting point and the target point as the input parameters here. So now we need to have the default detect here, right? And we have to assign that with the starting position as 0 as well. So here initially we will assign the value of the default data value as infinity using the lambda function, the key value as infinity. So and t of s is equal to 0. Now we are using the heap here, and we already have the starting point and the starting node, which is 0. So the tuple will be 0 and s, right? So sorry, this will be the weight and the node, starting node. So this will be weight and start, right? So while we have the tuples inside the heap, we run this while loop and we pop the minimum value out of the heap. So heap q dot heap pop heap, and now we will be iterating in the adjacency the node, the menu, fetching the value by using the key. So for neighbors, this should be the first one, should be node, right? We are using the node, and then okay, so n and neighbors in adjacency node, right? We are here, which we are getting from here. And now if the accumulated edge with the new edge, if it is less than the adjacent, I mean the d of default dect value, right? Where we are tracking the array, basically it's the array, right? So using that, if it is less, we will be updating that. So w plus this will be n is less than t of neighbor, then t of neighbor is equal to w plus n. And now we pop this with the added value with the neighbor as node into the heap and push it. So heap q dot heap push, we push in the tuple as w plus n and neighbor as the node. Now we will be returning as the output of the function as the d of t. So if there is any existing path, which this is the target path, so if there is existing path, it returns the value, else that will return the infinity value, which we have defined as the default here, right? Oops, this should be returned. With this being done, the next part is to create the length set. Basically Why are we creating set? Just to avoid the duplicate lengths basically. So length, let this be lengths equal to this should be no, this should be set. So set of length of the words for words in original, right? And this should be sorted, so we are using the sorted function to make this a sorted one. So yes, this should be sorted, right? Yeah, sorted. So we have this length set available. So what happened? Yeah, so now the next part is to create that dp function. So dp, and this will accept I, the index, right? And now we have to write on the base case. So the base case is if I equal to len of source, then return 0. So this is the base case. And if source of I equals to target, right? So in that case we have to jump to the next. So we will have the best is a target of I. So best equals to dp of I plus 1. So which means this is we will move to the next next index, right? So with this, now if there is if this this condition does not get executed, the best will be, for now it will be infinity, right? We can assign to infinity for now. So because it should be updated with the minimum value, right? So best is equal to infinity. So now we have to iterate in lengths, and we have to find the best by the minimum by using the Dijkstra's algorithm and finding the best minimum value out of it, right? So for length GTH in lengths, so now we have seen in the explanation, right? So I plus length, that we will be comparing with the source. If it is exceeding the length of source, we break at this point. So if I plus length greater than len of source, we break this loop. And so source, yes, is equal to, we are creating the, we are getting the substring out of it. So source of I to I plus length, and in target also similarly, T is equal to target of I to I plus length, right? It's correct. Okay, so if not, we have to check if S is in the adjacency list. If it is not there, then we have to continue. We have to move to the next length basically. In the lengths array, the length set, we have to go to the next value. So if not, yes, in adjacency list, yes, yeah, adjacency list, continue. And now best is equal to min of best, and you have that source and target, which is this defined here, the substring, along with the dp. So this will be Dijkstra's source and target added with dp of I plus length, right? So now we can go ahead and return return best. So we found the minimum, so we can return best, right? And now the result will be equal to dp of 0, and we have to return result if result is not equal to infinity. So if there is no possible way, or the possible way to reach that node, then we will return -1, right? So in that case, else -1. And we need to add a cache function here to catch the dp of I value and cache it, so that in next time when we are at the same index position, there is no need to repeat the same operation. Similarly, we have to do the same in distras as well, so that we will have a reduced time complexity. So there is one more typo which I have noticed here, which is this should not be the square bracket. This should be, now this should work. And let us submit this. And there you go. This is a pretty efficient solution. Thank you.